Now we are going to see a problem from the topic of performance of boilers. Let us see the problem. A boiler, a boiler working at a at a pressure of 1.4 mega Newton per meter square evaporates 9 kg of water per kg of fuel burnt from feed water supplied at 45 degrees centigrade. The steam generated is 0.95 dry. Find the equivalent evaporation from and at 100 degrees centigrade. So here let us see the what is the given data. So if you see here the pressure, working pressure of the boiler is given, means at which the steam is generated, which is given as pressure is given as 1.4 mega Newton per meter square. So here we are converting this pressure 1.4 mega Newton per meter square into bars. So why? Because so to solve this problem we will use the steam tables. So in the steam tables generally you will we have to see the values against the uh, pressure and temperature, and that pressure is generally we will find in most of the books in the bars. So to solve the problem easily and to get the values of HF and HFG like that, so we are converting this mega Newton per meter square pressure into bars. So how means, let us see here. This is given mega Newton per meter square. First of all, 1 Newton per meter square is nothing but Pascal, and so it is mega Newton per meter square is megapascal, and here this mega is nothing but 1 mega means 10 to the power of 6. So it is 1.4 megapascal means 1.4 into 10 to the power of 6 pascals, and here this let us when you rearrange this 1.4 into 10 to the power of 6 Pascal is can be written as, just take 110 here, so it is 10 to the power of 6 is becomes 10 to the power of 5, so it is 14 into 10 to the power of 5 Pascal, and this we know 1 bar is equals to 10 to the power of 5 pascals. So this can be written as 14 into 10 to the power of 5 pascals can be written as 14 bars. So this pressure we are converted into bars. So that pressure is nothing but 14 bars, which is the given value. We are converted into bars, 14 bars. So here the pressure is 14 bars, and mass of this steam generated is given 9 kg of. So here 9 this is given boiler working at pressure of 1.4 evaporates 9 kg of water per kg of fuel. So here we have to assume that 9 kg of water is evaporated, means we just assume 9 kg of steam is produced. So here given for kg of fuel is given. So it is, let us take it as the mass of the steam generated as m. So 9 kg of steam is generated per kg of fuel is given for per kg of fuel bond means. So here mass of steam generated is 9 kg per kg of the fuel, and feed water temperature is given as 45 degrees centigrade, and that is we have written, and the steam is generated is 0.95 dry, means it is the dryness fraction of the steam, and let us take the steam is the exit condition as a 2. So the steam dryness fraction is x, and that is exit condition is 2, means x2 is 0.95, and we have to find out the equivalent evaporation. So let us indicate with ME. So let us find that ME here. So here if you see, for equivalent evaporation generally we will find these kind of formulas here. There is only a little bit change MS and M, and the remaining formula is same. Let us see the formula. ME is equals to MS into H2 minus HF1 by HFG 100, and this formula we will use when the mass of the steam generated is given kg per hour is given. We will use this formula to calculate ME with this formula, and we will use this formula when the mass of the steam is generated is given per kg in the kg per kg of fuel, means mass of the steam generated in kg per kg of fuel is given. So we will use this formula. So both are same, but just here ms and m, the notations are a little bit changed. So when the mass of the steam generated per kg of fuel is given, we will use this one. So our problem is per kg of fuel is given, so we will use this formula to calculate equivalent evaporation. So the second one we are using. So if you see here, so this let us understand the meanings here. So ME is the equivalent evaporation that we have to find out. M is the mass of the steam generated per kg of the fuel, and H2 is the enthalpy of steam produced at the given conditions. So given conditions means see friends, we have to find out the enthalpy at this 14 bar like that, and dryness fraction 0.95, and for that we will use the formula, and that is H2, that formula we will use, and HF1 is nothing but feed water enthalpy at the 45 degrees centigrade. So, let us see how to find this H2. So, H2 is the enthalpy of the steam produced at the given conditions, means at the 14 bar and at 0.95 dryness fraction, which is given in the question. So, it is given that the steam quality is 0.95 dry means. So, we can say that from this the steam is at the wet condition only. So, for wet condition, when you want to find out this enthalpy of the steam, the formula is H is equals to Hf plus x into Hfg, and we are taking the steam at the second as exit condition as 2. So, here we indicate with the 2. So, 2 indicates the exit condition, means steam is getting at the point 2, like that. So, the formula modified formula we can write as H2 is equals to Hf2 plus x2 into Hfg2. So, here these values we will find out from the steam tables at the 14 bar. So, let us find out these Hf and Hfg values from the steam tables. So, like this you will find out the steam tables, one table is you will get from the steam tables. You have to see saturated water and the steam tables, pressure based tables, because we are taking the values at the 14 bar. So, depending upon the pressure we are taking, so refer to the pressure tables. So, 14 bar, so check out where is the 14 bar is there. So, at the 14 bar we require Hf and Hfg values. See here at 14 bar we require Hf and Hfg values. So, at the 14 bar this Hf is 830.1. So, these values are given in the kilojoules per kg. So, at the 14 bar Hf value is 830.1, which we have written here 830.1 kilojoules per kg, and at the same 14 bar Hfg values, at the 14 bar Hfg value is 1957.7. So, that we have written here, and x2 is 0.95, which is given in the question. If you see here, dryness fraction is 0.95. So, we are taking the x2 as 0.95, which is given. So, when you substitute in this formula, you will get the H2 value as some 2689.9 kilojoules per kg. When you substitute in this formula and these values, and when you simplify, you will get H2 as 2689.9 kilojoules per kg. And next here Hf1 we require. So, here the Hf1 is the enthalpy of the feed water, and 1 stands for the inlet condition. So, here the we will assume that in general this feed water is completely in the liquid state itself. So, this enthalpy is taken as directly the enthalpy of the water at the 45 degrees centigrade. So, this will also find from the steam tables. So, let us take the temperature based tables. The table you have to find out from the data book. We will have temperature based tables and we have pressure based tables. So, let us see in the temperature based tables, because in the question it is given the feed water temperature 45 degrees means. So, the condition of the feed water, that is nothing but enthalpy of the feed water. So, we have to take on the basis of the temperature only. So, at the 45 degrees centigrade, what is the enthalpy of the feed water? Let us see here. You have to see temperature based tables, and 45 degrees. So, this is the temperature in degree centigrade. So, 45 degrees centigrade, what is the enthalpy? That is Hf, means enthalpy of the fluid, that is liquid. So, we are taking we are assuming, or in general we will take the inlet condition as completely liquid only. So, directly the enthalpy of the liquid at the first condition, that is 45 degrees, is the Hf1 value. So, here 45 degrees centigrade Hf is nothing but 188.4 here. So, that we will substitute here 188.4, that is the Hf1 value, and Hfg 100 means it is the latent heat of water at 100 degrees centigrade, and it is a constant value, will that is 2256.9. This also we can see from the tables. So, at the 100 degrees centigrade, what is this Hfg value? You can see friends, just here. So, here 100 degrees centigrade, it is a saturated water and steam tables. temperature base. So 100 degrees centigrade, what is the HFG value? 100 and HFG. So when you see 100 HFG, so this is the 2256.9. So this is also HFG value we find from the steam tables. So substitute all these values in this formula to get equivalent evaporation. See here, we got M is given in the question itself, 9 kg, and H2 we have find out 2689.9 kilojoules per kg, HF1 188.4, and HFG is 2256.9. So substitute all these values in the formula, that is M9 and H2 value and HF value and HFG values which we have calculated, and we are getting the equivalent evaporation as the 9.975 kg per kg of the fuel. So that is the equivalent evaporation we have to calculate from the given information. Thanks for watching. So for more videos, please subscribe and activate bell symbol. Please share it, like it, and don't forget to subscribe. Thank you.